Hey, this is Passy from Passy's World of ICT, the guy with the white hat, and we're back finally with a Python programming lesson. And yeah, it's been a while since we've done any Python. We had to build an Excel course and a Access course because of all that Chinese flu lockdown stuff. So that's all done, and we're getting back to some programming now. And this one is going to be our fabulous Tic Tac Toe game, where you can play Naughts and Crosses, or Tic Tac Toe as it's known, on the computer. Now, there have been some questions about why aren't we putting out a video every week like we promised, and also why do you have to pay for the lesson, printable materials and the code and all of that. All right, here's the deal, guys, that I'm only working part-time and doing some teaching, and then I've also got the photography business, which is probably still losing money at the moment. And I've got Passy's World, and that's all I've got. So I've got a really low income at the moment. So I'm working like 2 jobs plus another thing on the side as well. So, you know, I'm working up to 4 different jobs a week, which doesn't leave time to do a video every week, unfortunately. And then, so, you know, I expect something for doing this, and the prices of the materials are super, super low, and they'll help you out a lot. So just get them. Now, in this lesson, we're going to make this tic-tac-toe game. So what it'll do is it'll show you a grid. It'll give you some instructions here. And the grid positions are that this is a row, A, B, and C. We've got 3 rows here, and these are the columns, all right? So we got column 0. Now, why do we call it 0? Well, it lines up better with the arrays, okay, in Python. So we've got column 0, 1, and 2. So if I want to put something right in the middle, I want to actually put that on row B. And in terms of columns, I want to put it at 1. So that position's called B1 here, okay? Because it's row B going across, and it's column 1 going down, and that would be B1. This would be A1, this would be C1. So they're all labeled here. So we need to give that in the instructions, because this might be very confusing to the players when they first start off. And we've got some examples here. In the very top left corner, type in A0, or you can do little a0, all right? So you can see here, the top left-hand corner, when we look at that, that's here, because that's at A and column 0. So that's how you put something in the top left-hand corner. If you want to put something in the bottom right-hand corner here, well, that's on C, and that's at 2. So that guy's C2. This one here is C1, this is C0, B0, A0. After a while, you'll quickly understand what the grid's like, but first time it could be confusing, so we need to give them some good instructions. So that'll be another step in the process. And then we'll have to look at all the different ways there are of winning a tic-tac-toe Naughts and Crosses game, because you can go across ways in the top, in the middle, and down the bottom. You can go down ways on the left, in the middle, or on the far right. Plus you got the diagonals, kind of left to right and right going down to left this way. All right, so we got those 2 diagonals. So altogether there are 8 different ways of winning. Plus you need to think about, you can have no winner tie games. So altogether we've got 9 different outcomes resulting. And you might think, well, that's pretty simple, because, you know, 4-year-old kids can play tic-tac-toe. But no, in the programming, you'll see it gets evolved, but a lot of it's the same sort of thing. It's just that you're at different positions. You're trying to get 3 in a row. That's the idea of the game, 3 in a row. All right, so that's all of that taken care of. Now, let's have a look at another tic-tac-toe Python program, because there are plenty of them on YouTube and on the internet. And look, I'm not trying to diss on these other people or hate on them. I just want to point a few things out. So here's another tic-tac-toe program that was on the internet. So it does a grid like this, but it's all kind of squashed up against the left-hand side. It's X's turn, so where are you going to move? Well, I don't know. What is this place? What is its number? 1, 2, 3, or what is it? So it's not at all clear. There's no instructions on it or anything like that. What you're supposed to do is, it's quite clever. If you've got a number keypad on your keyboard, which means you'd probably have to be using a PC with a plug-in keyboard, because most laptops these days, they've taken off the number key. So you don't have the number keypad like this. You can buy little plug-in ones on Amazon. You can plug in by USB. But see, what it is 7, 8, 9 is the top part. The middle row is 4, 5, 6. So if you want to go right in the middle of the tic-tac-toe, you just type in the number 5. So you see how the guy's done number 5 here? Well, then you get an X right in the middle. So now it's O's turn. Now where does O want to go? O wants to go 7 up in this top left-hand corner. So I type a 7 and it goes in. So look, it's not all bad. It's a pretty clever idea using the keypad, but the trouble is most laptops don't have a keypad. Now what I don't like is the programming. Because they set up an array for the board, which is kind of simple, that it's 7 and you're putting a space in there. So they've just called them the names on the keyboard here for the locations. But then all of this here isn't exactly straightforward. That's not good code for a beginner. So I don't like that because it's not good for a beginner. So what I don't like about this is, just reviewing it, many laptops don't have the number keypad, but I do like the idea. That's very clever. I hate it. So many people have these console programs where everything's crammed up against the left-hand column. And I think I've done it in some earlier lessons as well. But I've decided that I don't like that. So I don't like that. And they could have used 2 spaces in here just to make the boxes a bit bigger and more square and matching. And, you know, this is very clever and efficient Python code. And by all means, once you've done our tic-tac-toe, go and look at some of the other ones on the internet and try and figure out how they're working, because you kind of really understand the game and the programming that needs doing after doing our one. And then you can look at other people's ones in Google and go to Stack Overflow and understand it. But look, these people are... What I found is, looking at a lot of programs that are on the internet, these Python programmers, they like to show efficiency and cleverness and all of this, which is great because that's what you should have in the language, but it's so bad for beginners. It's like if you wanted to take guitar lessons, you rock up and here's your teacher and he says, hey man, I'm going to show you the most evil, deadly, shredding metal guitar solo ever written. Okay, wasn't that cool? Now let's learn how to do that in 5 minutes. Well, you know, it doesn't work that way. That guy's been learning guitar for like 5 years probably to get to the level where he can play shredder solos like that. And that's what a lot of this Python code's like. It's shredder level code, if you like, if you're into metal guitar and stuff. And it's way too advanced for beginners and not like. So here's another example I found on the internet, program number 2. Now this one here has a really strange kind of version. In that it's all filled with 1s and 2s and O's and 0s. And what the hell does that mean? Well, one player is actually number 1 and the other player is number 2. And you can see here we've got 3 2s in a row. So number 2's actually won the game. And 0 indicates an empty square. But man, that is so far away from the X's and O's. And here's the code as well. And I hate this sort of code where there's not a lot of comments and they're using really small variables and X's and Y's and algebra type things. Like, sure, this is really efficient, really smart, clever code, shredder code if you like, but that is way too hard for beginners. So not like. The fact that it doesn't use X's and O's, it's out for me straight away. I don't like it. And it doesn't draw up a playing board at all. It just has this weird kind of sort of square bracket stuff going on, and that's not simple enough for a beginner. All right, so although this was someone whipping up something really quick in Python and using all the tricks, no good for beginners and no good for Passy's world. And here's the third one. This is one which one of my students actually made as an optional extra project. I don't know whether they made it or whether they got it from somewhere, but I haven't been able to find anywhere that has this. So I think they did make that themselves. But what they decided to do, which wasn't a bad idea, show people a grid. This is a grid 1, 2, 3, 4, 5, 6, 7, 8, 9. And you just put the number of where you want your thing to go. So it's always best to go in the middle. So this person's picked number 5. So their X goes in the middle. Now player 2, choose where the naught is, where the O is going to go. All right, so they choose number 1 here, which puts it up in the left-hand corner. But there's so many of these different numbers in the O's and X's. After a while, maybe you can see here a bit better. But I just don't like the grid cluttered up with other stuff other than the X's and O's. All right. And now the coding in this too wasn't exactly straightforward because, see, they've got this sort of while loop inside a while loop. They're just using A for input, like letters A, algebra type coding. Absolutely hate that. You should write long, meaningful variable names so that people know what the heck's going on. So not like. and the numbers cluttering it up, don't like the code, and all this crammed up against the left-hand side stuff, okay? So look, go back and find these programs and look at them. They'll teach you a lot of good Python programming. There's a guy who even has a whole series. He just teaches Python by making a Tic Tac Toe game, which I think is a great idea. And you'll learn some more in-depth Python. But look, for us beginners, you know, fun things we all can do is our mantra here at Passy's World of ICT. You'll see it on the banner on the YouTube channel. Fun things we all can do, okay? So that's what we're looking at. We're going to write a version that will teach you some Python. It won't show you all the clever shredder tricks, but you'll be able to understand it, all right? And then you can go on to other more complicated things if you want to and check them out on the internet. All right, so when you go to our website, passyworldofict.com and /Python, it's the same as clicking on this Python button and you will get all of our Python lessons. Now, the ones you need to have done in the course, because the course is made to be done in order, and it's best that you've done the arrays and lists and validation lesson, so you know about arrays and lists already in Python. It's best that you've done the rolling dice one, so that you know about random numbers and how we can convert random numbers into something useful we can use in a game. And the Hangman game has a lot of really good array processing and checking code in it as well. So ideally you would have done that one, because these projects get longer and harder as we go through, all right? So Hangman was quite a challenging one, and this one will be quite a challenging one as well. So this will be a long video, so we suggest you take breaks. So the learning objectives here, as well as reviewing that Python from the previous lessons that we've already learnt, or you could try and jump into this straight away if you do have some other Python experience. We're going to learn how to use arrays for storing and processing our information. We're actually going to use a Python dictionary to store a set of valid values that people can put in for grid references. So I think that's a new thing we haven't done before, the Python dictionary, so that'll be good learning. We're going to use that random number generator so we can choose who goes first, because it's unfair if X goes first all the time, because you have the advantage if you're the first player, because you're always one turn ahead of the other player. So we'll randomize it. So sometimes the computer will pick that X is going first, sometimes it'll pick that O is going first. We're going to have a Python function as our def. So we're going to make a def subroutine that's a function. Now, we've done this in previous lessons, so it's good if you've done those. And this is going to do check for winner. So we're going to take care of that with a function, and you'll see what that's all about during the lesson. Now, once we've found, when we're checking all those combinations, if we've already found that they've got 3 across on the top row, we don't need to go check all the other combinations. So we're going to use return, this command return, which just jumps you out of the subroutine and stops doing any work in it. Okay, so that way you can exit the subroutine quickly. So we're going to be using that. As soon as we find a winner, we can exit, because we don't need to look for anything else. We're going to then have a play again functionality, okay, so that you can have an initialized subroutine that resets everything, draws up the original playing board all blank again, and you can play another game. So we're going to add that in. I don't think we've done that in previous lessons. We haven't had a game where we can have play again functionality. Now, as usual, using the Agile methodology to build and test as we go. I think the finished program is around 400 lines of code long. It does have comments in it as well. Now, you're not just going to sit down and start typing that and, you know, do it in half an hour and 30 minutes or something like that. So, and also, you know, if something's not working, you're going to go check so much code, because it could be anything. It's best to do little bits test, and then you know that little bit's okay. Go on to the next bit. And then if it bombs out and if it's not working, you probably know 99% that the problem is in the next bit. So this is how we always build the Agile steps. And if you've been doing our course, this should be all familiar to you. So step 1, we develop a playing grid. So we just get a playing grid showing. Step 2 is we give instructions to the players, all right? So when we finish those 2 steps, this is step 1, where we're just going to get that grid drawn up. So we're going to have storage areas to store the X's and O's, and we're going to have their locations in a grid like this, all right? So that's the first thing, to make that grid and to get it presented on the screen to the player. Step 1, test it. We just see that we get this top little bit working, and that's okay. Then we go on to step 2. Step 2 is where we give the instructions. So we need to print out all of this information and give them some examples so they know when they type B1, that's going to put their symbol, whether they're on X or O, right in the middle of the grid here at B1. Okay, so we get that done, we test it, we make sure it's working and displaying like this. Then we go on to redraw the grid so they can start the game, and ask them to put in a grid reference. So put in, A0, B1, C1 or C2, something like that. If they type in J4, then we need to give them an error and tell them what the valid ones are, okay? So we've got to do that as well. We've got to have error handling and validation. So you will have seen that in our previous lessons, or you may see it for the first time in this one. Then, of course, we need a loop so that people can keep putting in their X's and O's on this grid until one of two things happens. The game's over because someone's got 3 X's or 3 O's in a row and they've won. Or the other thing is, you've got to remember that if there's been 9 turns taken, well, that means all 9 locations on the grid are filled up, and so it's a tie game. So if we find that we count, each time we fill a grid position, we count it, and if we find that we've got up to 9, and we haven't had a winner, well, then we know it's all finished and it's a tie game. So don't forget the tie game. A lot of people just look for the wins and forget about the tie game. All right, then we need to create alternating turns so that X goes and then O goes and X and O up until we've done 9 turns, and then we finish if we have not had a winner. If we have, as soon as we do have a winner, we finish the program. We're going to add code now to process the player's input position onto the grid. So we get the input from them where they want to move, but then we need code that's actually going to go to the grid and put their symbol, their X or O, in that position on the grid. Okay, so we've got to get that. And then the check for winner. This is a big piece of code. We will do we'll do 3 check for wins for you, which means that you've only got, I think, 5 other ones to do, okay? And that'll be a challenge task just for you to do the 5 other ones. But look, it should be easy because you can just copy and paste the code we've already done for the 3 we've done in this lesson. And we're going to have generic code too, so that it'll work for either X or O. It can check for both players winning. We don't have to have a separate check for winner to see if X is won and a separate check for winner to see if O is won. We can just have one check for winner def, and we'll show you how to do that just with a little bit of slightly clever coding. Then challenge task 2 is to add code to randomly decide whether X goes first or O goes first. And then we've got play again functionality, so they can play another game. That's going to be challenge task 3, and we'll give you a few hints about how to do it, and then you'll have to finish it off, and that'll consolidate your learning. And this lesson also has a super challenge task, our first super challenge task, and we'll talk about that later on. Now, there's a 21-page PDF step-by-step instructions document. Now, you need to get that for this lesson, and at the moment, before the new year, it costs about $2 US. We will be having a price increase in 2021, but it's still going to be like about $2.50, under $2.50 US, okay, which is really cheap to get 21 pages. So, it's about a little over 10 cents a page of learning. So, and we'll show you the pages in this lesson, the video, so you can decide for yourself as well. Now, challenge task 1. Okay, we're not ready for challenge tasks just yet. We are stopping right here. And then we're going to go across and have a look and start making our program. All right, so if you need a break, this is a great place to take a break. This is the end of sort of the introduction and overview. So take a break now and then come back and join us. There's a timeline index in the video, all right? So remember, use that timeline index to take breaks, and you can come back and just click on where you're up to, and it'll just start the video from there. All right, even if you've been out of the video and you're coming back into it, it'll just start it from there. And also remember that with that tools cog, like we showed at the start of the lesson, which we did not show at the start of the lesson, we just realized. Okay, so we might just fix that up quickly and show you that as well. Play speed, this is something we should have shown in the original Python lessons, but we've been doing it in our other Excel and Access. So I think this one's for Access anyway. But look, we're a slow talker, so make sure you increase the speed, the play speed of the video to 1.5 or even 1.75 speed. It'll flow a lot better. Now, how you do that is on the tools cog, at the bottom of the YouTube player bar, you'll see this little round circle cog thing that says HD on it. You need to click on that and then pick playback speed and make it 1.5 or 1.75 and then just click off that, and that'll make the video flow a lot better. Now the timeline index, this is a quick lesson. No, this is a long lesson. You'll need the index actually, but the idea is that in the video, you'll see this is for a different lesson, but there'll be time. So if you've finished here on database table, say, come back to the video another time and you know you did database table, so you're up to here. So you just click on that 1506 and it just jumps to that section of the video and starts doing it straight away, okay? So take a break now if you need to, and then we're going to start the lesson and start at step 1, where we're going to make the blank board for the game, or the blank grid. All right, welcome back. So here we are. This is where we've got, this is what you get with the downloads. This is a 21-page document. So step 1's drawing the grid. So I want to make this blank grid here, and it's a reference grid. Now, here's the code to do it. So, you know, if you want to, you can just pause the video and use this code. Now, have I got it all showing on the screen properly? Yes, I have. All right, so remember that they're just the comments with the little hashtag sign on them. Then we've got def, Tic Tac Toe main. So this is the main procedure. And down in column 1, at the very bottom of your program, remember in Python you have Tic Tac Toe main to make it get executed. Now we've got a def here where we're going to set up 3 arrays. Actually, we're going to have a separate array for each row. So this is grid row A, and we're just putting blanks in the 3 positions. This is grid row B, grid row C, and we're putting blanks in those. Now, if this looks really weird because you're doing it for the first time, you need to go back and go to our course, go to Passy World of ICT website and do the lesson on arrays and lists so that you know what this is all about. We're assuming you've done that. All right, now to draw the grid, we just need to do a whole bunch of printing. So we're kind of printing spaces to move it out from the left-hand side so it's not all jammed up. We're putting the A, B, C down the side for the rows. We're putting 0, 1, 2 across the top. We're putting some dividers here, all right, so that you will actually see the thing in grid form. And then what we're doing is you have to use the str, the string command, and take whatever is in grid row A, position 0 here, and that's what goes in here, all right? So we're just adding this with a concatenation. Now, we're not going to explain all of that, how it works. If you've been doing our course, we've done joining things together in strings with the plus sign before. I think we've done the string function before. We've done arrays. So when you want to get this, what's at this 3rd position here at A2, you just need to have string brackets, grid row A, square brackets 2, and then 2 normal brackets to close it off, all right? So that will print out the grid. And so the main processing is we're going to print, and we're also just going to have a welcome message. Hey, tic-tac-toe, here we go. Then we do draw grid, which is this def up here. Now, the indentation turned out a bit funny, a bit strange. I'm not sure what was going on, but we found that this had to be in column 1 for some reason, and this def had to be pushed across. Normally we would have thought it'd be here, or we'd have both of them pushed across, 1 tab, key space, but for some reason PyScripter was playing up and it ended up like this. So anyway, typing it in like that's fine. It still gives you easy readability and it works. So, all right, get that typed in, and when you have typed that in, what should happen is, we should be in the Python course here. All right, so number 1. So here's our first Agile version. What it should do is it should have that and the grid and press any key to exit game. All right, so here we are. So you need that dummy input too to keep that on the screen when you run it in Python. And remember, we're running it from Windows Explorer. So you need to kind of run it in PyScripter, then go to Windows Explorer and double click on it to get the console version. That's what you should get like that, all right? So that's what you're aiming for. So pause the video and get that typed in and get it working. That's step 1 done. Okay, step 2 is to get all the game instructions. And if we have a look here, these are the game instructions where we're telling them how this grid's laid out and giving them some examples of what they type in if they want to set their symbol to a certain location in the grid. So if they want to go at the end of this middle row here at B2, they need to type in B2, then the X or O will go up here in B2. So that's the idea of it. So we need to get that done. Now to get that done, it's just a whole bunch of printing again. And here's the code to do it. So we've already got our draw grid. Okay, we've got that done previously in step 1. So here we are, def player instructions, and we're just going to draw the grid again. So we sort of copy and pasted that code, but instead of having string grid row A, we've just hard coded in that A0, A1, A2. So it's going to put the grid locations on there when it draws it up. All right, then we've got these examples here that we're giving them. All right, so when that is done, which is just this player instructions, now you have to tell Python to do the player instructions. A common mistake our students have all the time, we've noticed, is that they put the def in like this and get all the stuff, and then they're running their program, they're saying, I've added the code, and nothing at all is happening, absolutely nothing. That's because underneath at the very bottom of your program, where you're setting up the main processing and we had it do the draw grid def, you need to put player instructions bracket, okay, just in this spot here, which is the name of this guy, player instructions brackets, and it's going to be spelt exactly like that and all those sorts of things. Okay, so pause the video, get that typed in, and when you test it, let's see, we've got number 2 here. This is what should happen. It should just run, okay, and it's still done this bit, step 1, and here's where it's doing step 2. So that's what should be output. This area in here with the instructions should be output when you have put in this player instructions code and got it right. And remember to have player instructions actually get called down in the main subroutine at the bottom. All right, so let's just see if we can jump across. No, we can't cross the page. All right, so get that typed in, get it working, and that is step 2. Number 2 is done. Okay, step 3. All right, so I've already been going for 30 minutes, so it's going to be a very long video, but this, you know, think of this, other people have done this as like a 6-part series, but we like to sit down and just give you the whole thing in one hit, so it all links together, okay? But look, if you've done enough for today, just, you know, stop the video, pause it, and you know in the timeline index, you can come back and work on step 3, validation loop for player input. So, what do we need here? We need to set up a repeating loop so the player keeps getting asked for input until they've put in the right stuff. In case they're doing the Homer Simpson trick and just typing J4, Z3, P8, anything they like. Remember, our grid only has A0, A1, A2, B0, B1, B2, C0, C1, C2. That's all you're allowed to type in, one of those 9 things. These are the valid grid IDs right here. All right, now that's the validation check we're going to do. And we're going to use a Python dictionary to use it, which is pretty cool as well. Now, they might happily pick a valid grid location, but the problem is that we've got to make sure that the other player isn't already there. Because if the other player's taken that grid location, if they've got an O in that location, we can't let player X just put an X over the top, unless you want to make a whole new version of Tic Tac Toe. So no, the rule is that when it's occupied, it's unavailable. So we need to check for that as well. We need to check, see if it's blank, and if it's blank, it's okay for them to put their symbol in. If it's not blank, well, then we have to say, sorry, you've got to pick another location on the grid because that grid position's already filled. Now we're going to use a dictionary calling a function, inputs and passes back the actual grid contents, okay, to do that second check. All right, so the first step is to code the list of valid input values at the top of the program. So see where we had the def tic-tac-toe main at the top and we defined our array, our storage array. Underneath that, you need to put this code that we have a valid grid choices list. Make sure it's spelled exactly like that with an underscore character and then a shift minus. And our valid values, that grid entries you can put in, A0, A1, A2, B0, okay, those 9. Now, some of you might be thinking, what about little letters? Why can't they put in little A0? Because not everyone wants to type capitals and that. It's extra typing. They don't want to do uppercase. Okay, we're going to take care of that with a Python function. Don't worry about that. We just got those 9 ones with capital letters. So what we're going to do now is after draw grid, this is down the bottom in the main processing flow for the player, we set it to current player turn is X, so that's a variable, current player turn, it's got to be spelt exactly like that, and we're going to have current player turn symbol as well, just to make it clearer. You could just use this variable for everything, but we're just making it clearer, having 2 copies of it, that it's running with player X here to start off with, and the current player turn, plus if we connect up the symbol X with it, it's just going to say that it's X's turn at the moment. And then we want to do this new subroutine, get player grid choice. Now that player grid choice subroutine needs to check that they put one of the 9 valid things in, one of these 9 that we've got in our valid grid choices list, has to be one of those. And as a second check, it has to check that the grid they want to go on, okay, is already is available. It's blank, it's not already filled. So 2 things to check: valid grid type location, and that grid location is empty and available for them to put it into. So that's the bit that goes in the main processing at the bottom. Now the actual player grid choice, can we make that a bit bigger maybe? Yes, we can. All right, so this is the code that types in here. So we need valid grid choice input is false. We assume they've done something wrong, and we assume that it's maybe not available. So we set those both to false. And then we're going to loop through and keep asking the player for input until they enter a valid value. So while valid grid choice input equals false, or the available grid location equals false, okay, remember you use your double equals for when you're checking, player grid selection is keep asking them. So if they haven't got a valid grid choice or the grid location is not available, then keep asking him. Type in the grid choice for your symbol, e.g. one of A0, B2, C1, etc. Now we're going to use the upper method to convert whatever they've typed in to capital, big letters, big A0, big B2. So it's fine for them to type in little a0 and little c1, you know, we're just lowercase, but we're just going to put it all in uppercase to make it easier. All right, so player grid selection, we're just going to redefine that and make it equal to whatever they've put in and use the dot upper brackets. Now this method, this dot method function on the end is built into Python. By putting dot upper brackets, it'll convert whatever they've typed in to make it all in big uppercase letters, all right? If you leave those brackets off, very important to put them on. If you leave it off, it'll just say, oh, this is a function. It'll tell you you're asking it to do a function, but it won't actually do it. It'll end with an error code. So make sure you put those brackets on the end. That's really important. And it kind of looks weird because you're going, oh, there's nothing in the bracket. Shouldn't there be something there in it? No, they're just a set of brackets you need. So that's the first part there. All right, so we get their selection off them, we convert it to uppercase, and then you keep typing, and we have from there, that's what we were doing. Now, if the player grid selection is in the valid grid choices list, remember we set up that list up earlier that has all of the A0, A1, A2, all 9 of them in that list. So this is how we use the dictionary. That's a dictionary. We're looking up in that dictionary, checking out what they've put in, and seeing if it's one of those items. So if they put in like Z22, that won't be in the valid grid choices list that we set up in the program. So this will stay false and it'll keep looping and ask him to put in more input. Try again. Okay, but if they have got it right, well then we can say their grid choice input's good. So we can set that to true. Now, if they got it wrong, this won't happen and we need to print out something to them. Tell them what their grid selection was, like Z22, and say that's not a valid grid choice. Valid choices are as follows, and then we can just print out that grid choices list. We can actually put that out on the screen, show them what our dictionary is, show them what the valid ones are that they need to put in. You'll see that shortly when we run the program, okay? So that's the first bit, just checking that they've put in an A0, an A1, an A2, a B0, B1, B2, C0, C1, C2, one of the 9 valid ones. If they put anything else, they get this error message. It keeps it false, and the loop keeps going around, asking them, tell us where you want to go, tell us where you want to go on the grid, until they get this bit right. Okay, now after they've got this bit right, once they've got that bit right, then we need to check and see if that grid position is actually available. Make sure it's empty and there isn't someone in there. Now we've got a temporary thing here that we were just setting grid row 0 to X and putting something in grid row B as an O, just to make this, so we had to have something in there. So we pretended with this code that there was already an X in the top left-hand corner and B1's that middle location. So there's already an O in the middle. And so if they tried to go in the top left-hand corner in the middle, should get the error that there's already something there. So this was kind of code we had to temporarily set up. It's called a stub, so that an A0 should fail check and putting in B1 should fail check. All right, now here's how we do. We pass what the players put in, their valid grid selection, into a conversion subroutine, which is going to look up that actual selection in the array. So it's actually going to find out what is actually in that storage array that we set up with the 3 different rows, 3 arrays, and check that it's empty, okay? So we pass their player grid selection in brackets, and we use a function here that's called player input array lookup. That's going to be our function that we're doing. Now, if you've done our previous lessons, this should make sense about using functions. And so after it's done the function, it's going to come back into processing here, and we'll check if the Python array locations, if it's passing back that an X or an O is already there, well, then it's not available, all right? And we need to tell them it's already taken. Please choose a different place on the grid. We keep available grid location false, which will keep the loop going to make them keep having to put in input until they get it right. But if it's not an X or an O, okay, well then it's something else which we don't care about, and it's fine. They can put their symbol in there. So we set available grid location to true, and that's going to now stop the loop because it's a valid grid location and it's an available one. They'll both be true, so the while loop will stop that we set up earlier. Now, finally, we need to write this function, this player input array lookup. So you've got to get all that typed in. All right, then you need a whole new separate def. Now, here's how we do the array lookup. Okay, now player choice is what their value is, like whether they've picked A2 or B1. And what we're going to do is if they picked A0, well, that translates into being grid row A. That's the array that it's actually stored in the game, and its location 0. That's why we sort of set up that grid the way it is. If they put in B2, well, they need to go to grid row B and go to the location in that array right at the end, which happens to be number 2. All right, and check if anything's there. So this is just for error handling. This doesn't usually get done at all, but Python array location contents equals the location lookup, get the player choice. Now, if it can't get a choice, it's invalid user input. Now, this should not happen because we already had that other routine, remember, to check that they had a valid A0, A1, A2. So this actually won't get done, but that's an error condition if it wasn't any of these, if they weren't found in the lookup list, all right? So we've sort of got this brackets, curly brackets here, which is important. That's a location lookup sort of cross-referencing dictionary where you can look up that a B2 is actually grid row B, position 2 in that array. All right, so it should just pass back the location lookup result, and we get it to return the Python array location contents back to this one. All right, and that's where it checks. If Python array location contents happens to be an X or an O, that's trouble. That means that grid location isn't available. But if it's anything else, it's okay, and they'll be given the green flag, the green light, if you like, to put their particular X or O symbol in there. All right, so that's a bit of code. So you're gonna have to pause the video and get this def typed in and get all of this code starting here. So this is where it starts, def get player grid choice. And all the way down here, that's all part of get player grid choice. And then this is a separate def which goes, does it go above it? I think it would go above it or below it. I think it works okay, either way. Okay, 2 defs to type in. And when you get those defs working, what are we on? I think we're on this one now. What you'll see happen is that, okay, we've got the instructions. We tell them how the grid looks. All right, so that's steps 1 and 2. Now into step 3. So it's set the current player turn to X and it's showing that player X. So we type in a grid choice for our symbol. All right, so let's be silly and we want to go at P88. All right, and we'll press enter. Now it tells us, because remember they're the valid ones up the top here that we gave them in the instructions, but the silly Homer Simpson has put in P88. P88's not a valid location choice. You need to do A0, A1, A2, any of these 9 are okay. So type in the grid choice for your symbol. Now remember how we set up in the code with those stubs that A0 actually has something in it, although you can't see it here. So let's try that out. We'll try out A0 and it should tell us it's not available. No, this is the next version where A0 is available. Okay, I think we've jumped ahead versions here. All right, let's go back to this one. Sorry about that, guys. So many versions. That's the thing of Agile. You end up with so many versions. And look, save each version separately so you can just go back to it separately. Don't keep saving over the top. Like just do a file save as when you're ready to start version 3, file save as version 4. All right, so let's try A0. Now, what's it? Location A0 is already taken. Okay, see, it's showing us an X, and remember we put those stub code in there. So if you try and pick B1, all right, it tells you B1's already taken because there's an O in there. Please choose a different grid location on the cell. All right, so we want to choose, let's say, A1. This location here, A1 right there. So let's type in A1. Notice we can put in little letters and it just converts them to uppercase. Okay, so that's all working as well. A1. Now, it did not, please choose a different location. It doesn't put it in A1. What? Because we haven't written that part of the program. All right, all we've done is where we're up to is that we've got the grid happening and they can type in. Now, if they put in P88 or Z54 or something really silly that's not one of the valid choices, okay, it'll tell them that. And if they try and go where we've already invisibly put some characters with that stub code, it'll tell them that location's already taken. But we haven't processed it to actually put their symbol in the array. That is the next version of the program that we're doing. Okay, so we've done version 1, display the grid. Version 2, give them instructions. Version 3, set up so that they use that grid and they put in the right sort of grid notation for our board of 9 locations. And the next thing is make sure that that location is already taken by the other player. And that's it, that's step 3 done. All right, so here we are when we test the code. If they go here, that should be fine. Okay, so it just goes through to press enter to exit the program. If they try and put it here, it tells you it's already taken. And if they're trying to put it there, it tells us it's already taken. So we've got that dummy stub code. Now we will have to remove that to make later on, okay? Now, test 3, player enters a non-valid grid location. So if they put in 1B, if they type it in back to front instead of B1, they put 1B. 1B is not a valid location. You've got to do A1A, but those 9, they're the valid ones. So please type in a grid location. So they've got to type it in again here until they get it right. And I'll keep looping around until they get it right. Okay, and until that's available. Now, the how functions work, if you've totally forgotten about that, because this is where we used functions in this step 3, if you've totally forgotten about that, remember this is the explanation I think we've given you previously. Think of a function like being a vending machine. When you're at the vending machine, you input money, and you also put input like number 53 if you want the Kit Kat here, which would be my choice because they're yummy. And what you do is you put in your 53 and your money, and then what happens is the machine processes that and it passes you back the Kit Kat, all right? That's the output. So what we were doing was we were putting in the player's grid location, like say they'd picked B2, that's what we were putting in here. The program was working out, okay, let's check out B2. Well, B2 is an okay sort of thing to type in. It's not something back to front like 2B, and it's not something silly like Z88. It's okay. And then they need to check also that there wasn't another player there. Just like the vending machine needs to check that it's still got Kit Kats and these haven't ran out yet. All right, so if everything's okay like that, then it can pass you back that everything's okay and give you a Kit Kat. Now we've got to work on the give you the Kit Kat bit. We've got to work on putting their actual thing in onto the grid and showing their little symbol appearing after they've done all that step 3 processing. Now we also did functions back in the drawing course. So remember we said the Python drawing course was a great way to start learning how to use Python. A lot of people will have just gone, oh, drawing, that's kid stuff, that's baby stuff, I'm not doing that. Well, we actually used functions here to find how we could draw a square. And then once the turtle knew how to draw one square, it was very easy to keep using that function to draw bigger and bigger squares. Okay, so if you did that lesson, you can, or go back and review that lesson, you will understand functions. Okay, so that's all good. So how functions work, all right, so you've got that in the instructions. We need to move on. Place the player's symbol onto the grid. All right, so take a break. I suggest taking a break because it has been 47 minutes. Oh, this is going to be the very longest of longest videos, but it's been about 40 minutes already. But look, it saves you doing parts 1, 5, 6 and trying to find them in different videos, all right? Just having it all in the one video, and you get the full set of printouts, instructions. Make sure you get the printout instructions, they're essential. Okay, take a break. Okay, just realized we were chewing gum during that last bit. Very unprofessional. All right. Step 4, place the player symbol on the grid. So we've got a grid locations available. Now we've got to get their symbol into that location. So remember what we've got is we've got this actual array. This is inside the computer's memory. So if they've picked B1, in this second array here for grid row B, we need to put something in here that's their symbol, either an X or an O, in that middle spot in the array in memory. And then it'll actually print out on the screen. So remember this stuff on the screen, the grid locations actually translate into 3 separate arrays. An array to store these 3, an array to store those 3, and another array to store those 3. Now, in other programming languages, we could use select case. But anyway, we did all this Googling and checked Stack Overflow, all this stuff on the internet. It looks like Python doesn't have case, which surprises me because plenty of other programming languages do, and I love using a case statement for something like this, but we can't. So step 4, we're just going to do it with the normal sort of if-else stuff, if in Python, and we'll do that. So first of all, you've got to delete these 3 lines. So where we set up that stub code to have X and O already taken up in positions, and we also had a temporary stub to draw the grid to show that these were taken. Okay, need to get rid of all of that. So where those 3 lines of code are in version 3, in version 4, just get rid of those straight away, delete those 3 lines. Make sure you keep the if statement, if valid grid choice input double equals true. Make sure that doesn't delete, just get rid of those 3 lines. Now we need to make some global variables here, which means they can be used in more than one def subroutine. So we're going to set a global variable back where we've got this definition player grid choice. Okay, that's where we were making sure that they had a valid choice. In step 3, that's what we're just doing. We need this global player grid selection, make this variable global so I can reference it. So global, you just type global, the word global, that's a Python word, that's why it comes up in blue. We loop and keep asking player for input, so we've done all that. So we just need this global thing added in at that location in the step 3 work we did. And we also need to add it in down the bottom here that have a global current player turn symbol. So make sure that's there so we can look at that across multiple defs. Okay, and get that done. So that's just 2 simple lines of code to do. Now we need to create a call to the new step 4. We're going to write another def subroutine, And this is why we do subroutines, because, you know, steps 1, 2, 3, all the other defs are working. So if there's problems come up while we're testing, we'll know that it's just in this def 4 subroutine where it is. So this subroutine is going to be called place player symbol onto grid. All right, that's a good name for it. I hate these programmers that will just put something like PPG for place player grid or something like that. Or worse than that, they'll just put G. That's how they'll name their def, all right? This one's called place player symbol onto grid. So that's what we're going to do. So this is down the very bottom of the program. That's the very end of the program there at the moment. So make sure you put this in the right spot. This isn't the def. This is telling it to do the def. Place player symbol onto grid. Now we need to code that def, and this is going to be the def. Place player symbol onto grid. So pause the video and put this in. What it's going to do is that it's basically saying, okay, if they've chosen A0, we need to put their current player symbol, whatever they are. If the current player's turn symbol, if it's on player O at the moment, that will be the value O, and it'll go into this location on the grid. Okay, and then once we've got it in its right grid location, we just redraw the grid and you'll see the player's symbol there in that location. So we've just got to check out all 9 different locations, okay, that are possible, and then get it in the right position in actual computer memory in the array. So that's what that's all about. Just using a big long if-elif. In other languages, you could have used the case, which would be much cleaner and nicer, I think, but just this way's fine, it works, it's good. Just make sure you do your indents properly, and that's all good. So pause the video, get that typed in. Now, when we test this, what we should find is that if they pick A1, that should be okay, and it should put their symbol in A1. Okay, type in the grid choice for your symbol. It's player X's turn, so I expect you to see an X. They picked C2, which is right down this bottom right-hand corner here, so that works okay. Here they've decided to go with B1 when it's their turn, and that puts it in the right spot in the middle there in B1. Now here they typed B3. Okay, now B3 isn't something on our grid. They probably meant this last one here, which is actually at B2. So it tells them B3 is not valid, gives them all these options. They try out B2 and that's okay, and their symbol can go in there, all right? So step 3 error handling still working okay as part of step 4. And here they have picked its player X's turn and they've picked A2 and it's going in A2. Row A and column 2. All right, so that's good. So they can pick different locations and their symbol gets put in there quite okay. So that's all good and working. And we're ready to go on to step 5. And we better move on. Okay, so step 5. What have we got so far? We've drawn the grid, given them instructions. We've made sure they've picked a valid grid reference, like A0, A1 or whatever. We made sure there isn't the other player already sitting in that grid spot, so we've made sure it's actually available. We've actually put their symbol onto the grid spot. Now we need to make it swap turns. We need to keep all of that processing repeating, so it's going to do it for player X first. What we need now is some code to turn it over for player O, and we need to repeat that whole thing again for player O. Then when it's player X's turn after that, repeat it all for player X. So we need this loop. Everything we've done so far needs to go inside this big loop that can keep repeating. So we're setting up global turns count. Turns count is 0 at the moment. No one's had a turn. And this is in the main procedure at the very bottom. All right, so this is at the very bottom of the program. So down here, see Tic Tac Toe main is the last line in the program. So we're looking at just being above that. And what we're putting in is where it's got what player turn it is. We're not having it be player X's. Yes, we are having it being player X's turn still. But we need to put this in global turns count that there's no turns yet. And we need to do a while loop. And all this needs to get pushed across one tab key or 4 spaces so that it's all part of that while loop. And place the player symbol onto the grid, which we just did in step 4. After that, we need to have turns count equals turns count plus 1. Okay, so we can keep track of the turns, because remember, there's only 9 turns until the grid's full, if it's a tie game, or the game may even end sooner than that. Now, swap the player symbol. So we've done that, we've got their choice, we put that on the grid. Now we need to swap over. It was player turns X, make it player O's turn. If it was if the current player is X, swap it over to O and make sure the symbol's O. Otherwise, it's player X's turn still, okay? Because we must have just done player O's. That'll work. You could write it a couple of different ways, but anyway, this way works. So put that in and put that in, and that goes right in that bottom part of the program. So pause the video and get those typed in. And when we test that, what should happen is we can just do alternate turns and fill in all 9 grid locations alternating okay. All right, so what we mean by that is, let's just go to version 5 here and check it out and have a look at it. So let's make it big and long so we can see it. Okay, so starting the game. So the best thing is B1. X is going there. Okay, so it's O's turn, player O. We're going to go at O0. Player X goes at B0. And player O goes, oh, I better block them off at, well, player O doesn't block them off. Player O's silly and goes to A2. So player X can win by going to B2. But it's not over yet. Watch this. What? We've got 2 winners. Okay, we haven't done the check for winners subroutine yet, so the computer doesn't have eyes and it can't see, so it doesn't know if anyone's won yet, and we haven't done the coding to do that. So all we can do is we can just, the main thing is we just want to keep going and make sure it's swapping turns and it fills the whole grid. And see, now it's telling us to enter the key to exit the program. So that's good. We can go alternate player turns. It was going player X, player O, player X, and it stopped when the turns count got to 9, when we'd filled in all the grid. Okay, so that's all good. That's all we want to do. Now, the next bit is checking for the winner. All right, check for the winner processing. Okay, this is a significant part of building the game. It's kind of like if we were dividing the programming in 2, we'd pretty much have steps 1 to 5 as part 1, and then checking for winner and announcing the winner would kind of be step 2. It's kind of almost as big as what we've already done. So you might want to take a break now and just come back to this in the video timeline index, come back another day, or maybe in an hour's time, or after taking the dog for a walk or having a cup of coffee. Step 6, come back to this, check for winner processing. It's a bit quicker because you can get this download anyway and check it out. So basically working out whether players have 3 turns in a row. So remember, this is what we were doing in our steps, and we're up to this step, and this is the big step. And here we go. So there are 8 different ways the player can win tic-tac-toe, all right? So you need to, everyone should probably already know though about tic-tac-toe or Naughts and Crosses. You can get 3 winning rows across, so you can go here, here, and here, and O's can do the same. It doesn't just have to be X's. You can have 3 winning columns. You can go this column, middle column, right column. You can have the 2 diagonals. So there's 8 ways of winning, so we need 8 kind of different checks. And we're going to make this check for winner subroutine def. As soon as the player's achieved one of the 8 3 in a row outcomes, that's when we need to end the game. Or if all 9 positions have been filled and we didn't have anyone win, well, then we need to tell everyone it's a tie game and there is no winner. Okay, so we had our global's turns count equals 0. We need to add another one now, global game over, and then set game over equals false. And we need to do while not game over. All right, so instead of doing turns count, I think we had turns count less than 9 or something like that. Now we're doing while not game over. So we're changing that loop code. It's going to say while not game over. Okay, so that's the stuff we already had. This is the new one. After we've done the turns count up by 1, after they've placed the symbol onto the grid, this is our new one, check for winner. So this is down the very bottom of the program, right? Where you've got that main processing, where you just call the defs or name the defs that you want to do. Check for winner is the new one we want to do. Now we've got to write that check for winner. So let's just look at the first, again, we'll use Agile, we'll do this step by step. Let's just look at winning the first row, getting across the top here at A0, A1, and A2, all your symbol all the way across, and you win. All right, so what we're going to have is check for winner. game over and global turns count. All right, so we've got to have them global down here in the def, otherwise they can't get passed back to our main processing. So we check if 3 across on the top row are all X's or all O's, okay? So if grid row A happens to be all X's, game over, player X is 1, and game over is true, so that's going to stop the loop, and then we can just return to break out of this subdef because we're finished. Otherwise, we can check if grid row A is all zeros, then game over, player O has won the game. All right, so that's just how we check on that top row, grid row A, whether it's all X's or all O's and someone's won. Okay, so we had to check for X's and O's separately. Some other people's programs, what they do is they just check if there's an identical symbol all the way across. But we didn't like that method because maybe the symbols might not be X's and O's. Maybe they somehow snuck in different symbols or something. Plus, this makes sense. So you're kind of checking for X's and then you're just doing the same things to check for O's. If you find any winners, you break out of the subroutine using a return. It exits this def and goes back to the main process because we don't want to do any more checks because we've already found a winner. Once we got a winner, we got a winner. Now, check if 3 across on the middle row are all X's or all O's. Now, this you need to do as a challenge task, okay? So that's going to be for you to do. And finally, if no one's won the game, so if the turns count is 9, so this is the last check you have at the very bottom of that, check for winner, game over, no winner, tie game, all right? So if none of these trip up and return to exit, to jump out of the def, we don't have any winners. And if it's up to 9 things, well then all 9 squares are filled in, so our game's over. So we need to say that. So the challenge task is to copy and paste the above code and create checks for the B and C row. Okay, it should be pretty easy. Like this will just be grid row B. This will be grid row B. And then you'll have another copy of it where this is grid row C and this is grid row C. So we kind of designed having those separate grid rows to make the check for winner easier. We had that in mind when we started the design of the game. So here you can see when we test it works. That top one, which we gave you the code for, should work. Player X has won the game. Player O's won the game if they do those top ones. If we fill up all 9, game over, no winner. All right, so we're just trying to do this first row checking just for a winner. Just get that done or the tie game. All right, now we're going to show you how to do the left-hand column win, and then you should be able to do this column and this column. All right, so we showed you with that code right there, all right, just a simple if-elif, how you could check the top row. You should be able to change that pretty easily of copying and pasting underneath here to continue it to do the B row and the C row. We're going to show you how to do the down column here. You should just be able to copy and paste this to do the other 2 columns, just renaming it. Well, it's not going to be, we'll talk about that in a minute anyway. Okay, so this one, we need if grid row A0 is an X, B0 is an X, and C0 is an X. So this one's coded a bit differently. If that's an X, and that's an X, then player X is 1. Elif, they could, maybe there's all O's down this column, so let's check that out with this code and player O, and we stop doing any checking, we jump out of the subroutine. So this goes underneath where you've been doing your coding so far. So once you finish the rows, then we're doing the downs, the columns. Now you need to check if the middle column and check if the far right-hand column. Okay, so for 3 down the middle column, you're just going to be checking sort of grid row A1, B1 and C1. So these numbers in here in the brackets are going to change. And here you're going to be checking A2, B2, C2. So just copy and paste the code. But what you'll be doing is you're putting a 2 in here because we want to check these guys here that are in column 2 for the far right hand column. So you should be able to get all that working. And when you test it, that should all work. Now we'll show you how to do this diagonal and you can do the other diagonal. So this diagonal is just A0, B1 and C0. So we need to check those out. If those guys, okay, have X's in them, player X is 1. Elif, they might have O's in all 3 of them, and then player O's won the game. And when we test that, that works okay. Player X can win and player O can win. And that was the challenge task that we've been talking about. Challenge task 1, okay? So there you go. That's it. You need to get all that checking in. And also don't forget the tie game where all 9 squares fill up. Challenge task 2 is randomly picking which player goes first. Because remember, the player who goes first has an advantage because there's always one move ahead of the other player. Now, to make the game fairer, we're going to get the computer to randomly pick whether X or O gets to go first. Now, we do this by just choosing a random number value of either 1 or 2, and then we just map it. If it came up as 1 for the computer number, well, then player X is going first. If the random computer number comes up at 2, then player O gets to go first. So we've done random numbers previously in the rolling dice lesson, so if you know nothing about them and don't understand them at all, you need to go back and look at that. But what will happen is when you run this, here it's picked player O is going first, and here we've got the brand new blank grid ready to start, and player X is getting to go first, okay? So it should randomly just pick whether it's an X or an O on that. All right, so at the moment we've got code that sets up the player X goes first. So I want to take that code out. Okay, so that code there is the bit that we're going to change. And we're going to modify that player X code so it does something like this. You need to import the random number generator function in Python, or nothing will work at all. And we want to generate a random number between 1 and 2. So this is our pseudocode. This is in plain English, not in Python code. If the random number is 1, it's X's turn. If it's 2, it's O's turn. Otherwise, error in the random number generator. And we need to have that press any key to continue type stuff. All right, now we did this in the dice roll, so go back to that. Here's where you pick a number between 1 and 6 to get a dice rolled, all right? And if the dice roll value is 1, then we're drawing the picture of the 1 on there. So make sure up the very top of the program, you've got import random. So right underneath where those comments are, what version we're up to and stuff, import random has to be at the top. Make sure you don't forget to do that. And the only difference is instead of picking 1 to 6 here, this line of code, you need to change that to pick 1, 2. So it picks a number either 1 or a 2. Okay, and that should all be achievable. And this is the order you do things in. But we haven't given you a full solution. We sort of told you in plain English pseudocode what to do. We've given you some sample Python code to give you some ideas. You should be able to fill in the rest. And what will happen is you'll find that player O can go or player X can go. It's totally random. All right, now what is challenge task 3? This is challenge task 3. So third challenge is to have this reset processing. So if the game's finished, people want to play again. So here's some Python code to help you. You have something like play another game equals, get input from the user, a yes or no answer. If the player is yes in big letters, any of those types of doing yes is okay. Play another game equals yes. If not equals, which is exclamation mark equals in Python, so that means not equals. If they don't say yes, okay. So what we've done is we've converted all of these possibilities here just to be a yes. And if it's not a yes, which means it's not one of all those possibilities, we put in a thing for them. Looks like we're not playing more games. Get them to press the enter key to exit. And then when they do that, it'll quit the program and Python will end. Otherwise, we're going to do this new subroutine called initialize the game and then do our usual main routine. So, okay, now initialize the game is going to be a new subroutine def you have to write. And that's going to reset, set the global variable. So game over needs to be set to false, turns count needs to be set back to 0. And you need to set back all the arrays so they've got blank spaces, characters in them, all right? So that would be how you do challenge task 3, and we'll leave you to work that out. We've given you quite a bit of information there to help you, so you should be okay. Now, this lesson has the first super challenge task. Okay, this is the first, and this is because someone whose name I need to find out. Just hold on 1 minute. Okay, actually I might not shout out, but he knows who he is. So this is a guy doing GCSE in the UK, because we've got quite a few people in the UK tuning in the Passes World now. And what he's going to do is he's going to make a AI version of this. So he's going to take the tic-tac-toe game and have the computer use AI. And this is a super challenge task, and we have one person in the UK working on it already as we speak, and a good big shout out to him, and I hope he's going all right with it. Now, how do you do that? Well, it takes at least 5 turns before you can even get a winner in tic-tac-toe. So look, of course, we did some Googling on the web, and we suggest you do the same to see what other people have done, how they've approached this. But if the computer goes first, you've always picked that middle square, right? That B1 in the center. So make sure you pick that middle location. Now for turns 1 to 4, what the computer could be doing is, it just needs to go next to where it's already got an X or an O. Okay, so if it's playing X's, just try and get next to an X it's already got, so it can try and start to put a line of things together. Because no one can win during turns 1 to 4. It takes at least 5 turns until someone can possibly have 3 in a row. Now, from turn 5 onwards, the computer better get on the ball here, and it needs to check first, can it win? So it needs to check, okay, if I got 2 in a row anywhere, or if I got a way where I can just put my symbol there and I'll have 3 in a row and be a winner. That's the first thing it should check for. Then it should go into defense mode. If it can't find a win for itself, it better check that the other player doesn't have that situation. So you can kind of almost run the same subroutine, def checking, but this time you're checking for your opponent. And if they have a position where they could fill it in their turn, coming right up and win, you need to grab that position and block them and stop them. So that's the next thing it would do. And then if nothing in 1 to 4 is happening, so if you can't win, your opponent can't win and beat you on the next turn or anything, the strategy is to go around the edges, try and pick first up in any of the corners, their strategic locations, to have your symbol. So pick one of the corners that's available and get your symbol in there. If a corner isn't available, try around the edges. So try one of those top middle or top bottom positions, and always grab the center if someone's been silly enough to leave that free. Okay, so that's kind of basically your the winning strategy for tic-tac-toe, and that's the one the computer should follow, and that should make it sort of challenging and difficult to beat our AI computer. Now, when I've got time, I want to actually make this one myself because it sounds like a lot of fun, and there might be further down the track in 2021, there might be a Python lesson which actually shows you the AI computer version. But if you just can't wait, have a look at this one. There's a guy, Al Swaggart, I think his name is. He's had an ebook on Python. I think he's even put it out for free now. He's such a good guy, Al. And he's got some stuff here which looks really good. So check out that link, Al Swaggart's stuff. I hope I said his name right. And that's it. So have fun programming with Python. We hope you enjoyed this lesson. Get the downloads, and you probably have to go through it a few times. It's a complicated lesson. We've gone a really long time on this, so we need to wrap it up. And remember, subscribe to our channel, and that way you'll find out when the next Python lesson comes up. It might not be for a while because we're really busy working our other jobs. And there will be Python lessons coming in 2021 though, as regularly as we can do them. And subscribe. You know, get the lesson downloads so that I can pay my rent here. And we'll see you in the next lesson.